Thank you, Davera, for the introduction. Yeah, so we stay in the realm of data similarity because I will talk about comparing extracted concepts from text to the structured conditions in the database. Because at the Erasmus Medical Center, we maintain a large Dutch general practitioner database of 2.5 million patients. That is around 8% of the Dutch population of active patients. And while the structured data in the CDM is of course used for all kinds of studies and analyses, the unstructured text, the free text, or the unstructured data, the free text, that it sits in the notes table of the CDM, which is actually very large, 35% of the physical size of the database is unused. There's a lot of potential information unused. So to change that, we thought, okay, can we extract this information? Can we extract all the clinical concepts from the text and then use it in our analyses? So there are many tools to do this for English. However, there are not many tools to do this for Dutch. So I thought, okay, let's create a framework ourselves for extracting these concepts. So that's what we did. However, Dutch is similar to English in certain ways, but we still wanted to verify if our concept extraction was actually any good. So could we evaluate it? But that requires an annotated data set. So you do have multiple English data sets that are annotated with concepts, but that does not exist for Dutch, unfortunately. And creating one is a very laborious task, so I didn't want to do that. So we thought about this challenge and thought, okay, what information do we actually have for these nodes? Because these nodes do not exist by themselves in the database, because they often are linked to or occur together with a structured code, so a condition, for example. So then we thought about, okay, can we maybe use this structured data for evaluating our concept extraction, using the structured data basically as surrogate annotations to use it in the evaluation. And to do this, we thought, okay, can we just compare all the codes that we extracted, all the concepts that we extracted, with the structured code? Because if we can find similar or related concepts in the text, then the extraction works. And of course, concept can be the same. So for example, if you find COVID-19, for the condition COVID-19, you find COVID-19 in the text, that's the same condition. You can also find SARS-CoV, that's a bit less the same. You can find a vaccine, well, that is related. You also find the word car or the concept of car. Well, I don't see how you can connect those two. So we made our extraction framework using an existing open source framework called MedSpaCy. And we basically changed the structure of the algorithm by using a Dutch tokenizer, using SpaCy, a Dutch SNOMED CT dictionary for the concept extraction, and Dutch context rules for seeing if we can find any negations, for example. And of course, we stored all the information again in the node NLP table. Now, for the experimental setup, we looked at the most frequent, the 300 most conditions in the database. And for all these conditions, we took all the condition occurrences for all the patients, so that's around 30 million occurrences. Then we took all the nodes within a 3-day window around these occurrences, so that's 110 million. And then we extracted all the clinical codes from these nodes. That ended up like 430 million extracted concepts. Now, I said the assumption was that the text is related to the condition. Well, that might not be always right. Of course, there's always cases where the condition doesn't need any explanation, so there is no text. And of course, we're now only looking at conditions, so text can also be about procedures, medications, or other structured data. So that is, could not be relevant. So we still needed some ground truth. So that's why we annotated a set of 2,000 code observations or code occurrences, including 200 different conditions. And while you would normally annotate this text with saying, okay, here's this concept, here's that concept, here's that concept in the text, we now just said, okay, does this text describe a similar concept or a related concept? So this was very fast. because it is just 2 yes or no questions, so that 2 in this code occurrences annotated was done pretty fast. Now, to calculate the similarity between concepts, we decided to look at pre-trained concept embeddings, snowmed embeddings to be exactly. So these embeddings are created using a neural network and are a numerical representation of a specific concept, and therefore hold a certain semantic information of this concept. Then, to calculate the semantic similarity between the concepts, we could use the cosine distance between the embeddings. So, for example, COVID-19 and SARS-CoV have a distance of 0.87, and COVID-19 and CAR only 0.01. Now, to quickly say, okay, are the concepts that we find in the text, are they related to the condition? We just look at the concept with the largest similarity to the condition, just to make it quick. So we only focus on the concept with the maximum similarity. However, you still have only a number. So how do you say, okay, this concept is the same, or this concept is similar, or it's related? Therefore, we looked at the distribution of all the different 400 million extracted concepts that we found. We made a distribution of them, and then started looking at both the distribution and examples to see, okay, what kind of thresholds can we use? So for the related concept, we thought, okay, everything above 1 standard deviation of the median, those look related, and everything above 1 standard deviation from the max, so minus the max, those are actually quite similar to the original condition. Now, if we then used these same thresholds on only the maximum similarity concepts, we could then see, okay, in how many cases does the text describe the same condition as the structured data? So here we see that for the 30 million condition occurrences, that in 27% we find a similar concept, in 47% we find a related concept, and in 27% we only find unrelated concepts unrelated to the condition. Now, we also evaluate this on the annotated data set. So here on the left you can see the observed, so that's the annotated data set, and on the right is the predicted data set with the unrelated, related, and similar concepts. And here we find that in the 2000 occurrences, we found less similar concepts than we actually expected, but we did find more related concepts than we expected. We also find a bit more unrelated concepts than we expected. However, if we did not find a similar concept, then usually a related concept was found. So that was pretty nice. And if we look at this problem as a classification problem, then we can see that the related concept is quite good, better than getting a similar concept, but combining the both, then we have a pretty good performance. Now, in conclusion, we created a non-English extraction framework that we evaluated using the structured data. Of course, there are some limitations, but it is simple, language agnostic. Our framework performs relatively well. And we found that our assumption was quite true, that the related and similar concepts are found in the surrounding text of the clinical conditions. If you have any more questions or if you want more information, come to my poster at 504.